radical expressions. Radical expressions are expressions which contain radicals in them. We want to, in this section, we're going to talk about adding and subtracting radical expressions, and in order to add or subtract them, they have to be like expressions. And in this case, we can see that the 7 to the cube root of 5 minus 4 to the square root of 5, these are not like expressions, so you can't add those because there's nothing similar there. There's no form to simplify. Now this next one, where we do have what appears to be the same radical. So we have the square root of xy, and what we need to figure out is we have 3 plus 4 square root of xy, or we have 7 square root of xy. Like radicals, so we can combine those outside numbers, or what I like to think of the coefficients of these variables. And here, again, a like radical, the fifth root of 3x squared, the fifth root of 3x squared, so I have the fifth root of 3x squared, and of course 17 minus 15, right? And that gives me just 2 of the fifth root of 3x squared. And there you go, that allows me to combine those radical expressions. And in order to, these we currently had the simplified like expression. So now what we're looking at here is we do not have that. We have the cubed root of 250, the cubed root of 54, and the cubed root of 16. And let's go ahead and simplify those down some. And gosh, let me take a second here. So as I simplify those, it looks like I was able to find some cube roots here that are going to be like. For example, I'm going to have the cubed root of 2 times 5 cubed is going to give me the cubed root of 250, plus the cubed root of 2 times 3 cubed is going to give me the cubed root of 54, and then minus 3 times 2 times the 2 cubed. Goodness, I may have said all that stuff wrong a second ago, but what we can do is we can see that as we simplify this, I have the cubed root of 2, and then the cubed root of 5 cubed is going to give me a 5, because those are going to cancel out and bring that 5 outward. Now, then I have the cubed root 2, and the cubed root of 2, and again the cubed root of 3 cubed is going to give me a 3, minus the cubed root of 2, and of course bringing my 2 out. So I have been able to simplify these to the cubed root of 2, and then I have 5 plus 3 minus 2, which is going to give me, I think, 6 cubed root of 2. Alright, now this last expression here, this last example, is multiplying binomial radical expressions, and we are going to do this the same way that we would do any binomial multiplication, and we are going to make sure that we are distributing, multiplying the first term times all of the other, and then the second term times all of the other. So that would come to 3 times 2 plus 3 times 4 square root of 5. And again, I'm doing my order of operations. I just can't add or subtract before I multiply them out. And then I'm going to have plus 2 times 2 square root of 5 plus 2 square root of 5 times 4 square root of 5. Now I'm going to go ahead and simplify this. Okay, now I've gone ahead and I've simplified my expressions, and as you can see, we have simplified these, and I want to show you here where I have 2 times 4 is 8, then square root of 5 times square root of 5 is going to be the square root of 25. Okay, so right here, but what I can do is I can simplify this. Instead of 8 square root of 25, we know that that is going to be 8 times 5. And let's go ahead and simplify one more time. 16 square root of 5 plus 40, and all of that is going to be combining like terms to 46 plus 16 square root of 5. There we go. And that is multiplied and simplified. Okay, continuing on here, as we multiply, we're going to multiply conjugates. And what conjugates are the same expression, just with a opposite sign. And so in doing so, what we're going to do is we are going to, right here it's asking us, what is the product of this? What is the product of this? And we should recognize that these are binomials that we are going to have to multiply 6 times all of that, multiply 12 times all of that, and putting it out in all the steps. Let's see here one second. And in multiplying this, in some ways it's going to look like multiplying the difference of squares, because these conjugates are allowing us to eliminate the radical. And what I've done here is I've gone ahead and just shown you that we are multiplying 6 times the second binomial and multiplying the square root of 12 times the second binomial. And what we get is we get 36 minus 6 square root of 12. And then here we get plus 6 square root of 12, and then minus the square root of 121. And what I wanted you to see here is this. There's my conjugate. And what is happening here is we are eliminating this, because 6 minus 6 is going to give me 0. Okay, so I get 36 minus the square root of 121, or 36 minus 11 equals 25. There we go. And we have simplified that expression. Let's see here. Let's work on this next example. And, well, what I do know is I'm going to have 3 times 3, which is 9. This is going to be a positive 3/8x. This is going to be a negative 3/8x, which is going to cancel out. Therefore, I'm just going to worry about this. My last, I multiplied my first. My inner and outer cancel out, and then my last is going to be minus the square root of 64, or, sorry, 9 minus 8, or 1. So there we go. I skipped some of this step because we knew where we were going to be going with that center number. And let's try one more example here, and we are going to, goodness gracious, we are going to rationalize this denominator, and we are going to want to rationalize that denominator with a conjugate, and we will get to that right now. Alright, so now in multiplying by the value of 1, we can multiply anything by the value of 1 and not change it, other than making it an equivalent value but not changing an equivalent expression but not changing its value. So by multiplying by the conjugate, which you see right here, I have one expression with the minus sign, I have the other expression with the positive sign. And as we learned before, it's going to help us eliminate some of that center value, or when we're combining like terms. So as we look at this, I'm going to have to multiply 2 square root of 7 times the square root of 3 plus square root of 7. And then here, when I'm going to multiply using the FOIL method on my denominator, I know that the first is going to be the square root of 9. I know that the last is going to be minus the square root of 49. And then the inner becomes negative square root of 21. The outer becomes a positive square root of 21, or that's going to equal 0. So I am done rewriting my expression with a rational denominator. Now what we need to do is we need to simplify. I did note a mistake here, so just so you know, I need to make sure that I'm putting the right values in here. And that is a 7. So let's see here, plus 2 square root of 49, all of that over, this becomes 3 minus 7, 3 minus 7. We're going to simplify this expression right here too, because that should become 2 times 7. I don't think, is there a square root in here? I don't believe there is, so simplifying 2 square root of 21 plus 14 over negative 4. I guess we can simplify that some. We can simplify that to the square root of 21 plus 7 over negative 2. Because our equivalent expressions, that will decrease, and then of course that will decrease. So or simplify down. So I think we're done there. I think this is our final rationalized simplified expression.